start. So last time, at the very end, I started this idea of average versus instantaneous rate of change. If you were driving 95 miles per hour, how does the policeman know that if you did not drive for an hour? You just drove 20 minutes. That's a cool question. How do they know? Because they checked your speed right before and right after. That gives you instant change, instantaneous rate of change. While the average rate of change will be something like this, and I showed you last time, from 50, if you were driving 55 miles per hour, the lowest, 95 is the highest, but it was keep changing. The average will be something on average, like an average grade. Instantaneous one goes closer and closer to the point you choose where you want to find the instantaneous rate of change. So you pass by the policeman at this point, and the policeman knows that you are driving 95 miles per hour at this moment, even though you did not drive an hour. So we're gonna write down the famous formula of instantaneous rate of change. This formula will have lots of synonyms. We're gonna call it derivative, we're gonna call it slope at the moment, the derivative, and all that kind of stuff. So I guess I should secant. Yeah, I should do that. There are two different formulas we're gonna figure out in this class, and this is what a little bit confusing for students, and we're gonna stuck to only one, but they always introduce two. So m, the slope, equals, and you'll have the same thing. So fine, I'll just write down limit. The same thing I just wrote down, y2 minus y1. So let's do that, y2 minus y1 over x2 minus x1, where x1 approaches x2. Nobody does it this way, but it's kind of easiest way to understand the situation. The first time we had it, it was average. We call it the slope of a tangent line. Probably should actually mention that this average, this m belongs to secant, while this m belongs to tangent line. SEC is not seconds, it's a secant line. So average rate of change, it's a change in y over change in x, but it's not the one we actually need. We need the limiting position of a secant line. This is a weird phrase, but it looks like that I showed you before. Secant line cuts through, that's the idea of secant, cutting through, while tangent line touches. So we want that one. But to make it very close to the point, very close to this point P, we're gonna shrink inputs towards each other. And once input shrink, the output shrinks. So this is the formula. But it's not the way people usually write it down. It's not the official way. The official way is m. And from now on, I will not be writing down m tangent. In general, m is known to be slope of tangent, not secant. So I just keep it as m. Will be a limit. And then you will have f of x minus f at a, and that's what you'll be using in your homework, over x minus a, and x approaches to the point A. So x is a variable, a is the point where you want to see find the instantaneous rate of change. So it's, for example, when the policeman is standing there. The policeman will check the right, so this is limit from the left and from the right. That's why we just found it. We just learn how to understand limits. So the policeman stays here around A with this device. And then they call it a police trap, right? So you are going through. The policeman, the device of the policeman checks this limit, instantaneous rate of change at the device from the left and from the right. So x approaches A from both sides. When x approaches A from both sides, this denominator shrinks to 0. So the moment becomes instant. And that's why it's called instantaneous rate of change. So you don't have to drive for the whole hour. The policeman wants to know your speed right before and right after, from the left, from the right, and it gives the policeman the idea of your speed, miles per hour or kilometers per hour. So let's define that one more time. There's one more way to write it down. And that's why I think students get confused usually which formula to use. limit, this one is, I think, more popular using h. F, let's take the point A, this is where policeman is standing, and add, I don't know, A or X. I don't know, like how they do it with A. I guess let's keep it fine. This is where policeman is standing. Add a small change h to it, minus F at A over H. H is very known little notation in physics and mathematics to use something for a small change. H usually is something small. So being small means it shrinks to 0. And we're literally saying that H, which is in this case is x minus A from the previous formula, is a small change in input. Small change in input, like so. You will see it in further mathematical classes and physics and computer science as well as delta x. Small change in input is delta. This triangle means delta. Delta x. It's usually something small, by 0.1, 0.1. Delta. Let's see if this is all we need to know, and then I will tell you what is tangent line, equation of a tangent line. But the idea is we want to move from the average to perfect. Average was a secant cutting through. On average, this is my skill growth of dancing classes. When I joined the dancing class, I did not know how to dance. Then I got better and better. With time, I got better. On average, this is how well I'm dancing now. That's kind of, if you want to see it this way. But what about today? I went to class today to dance. How much did I improve today? How do you know how to find it? You find a little bit before and a little bit after. But how can I find a little bit after if I'm still here? So limit does it. It approaches the point from both sides. That's kind of the idea here. So we want to have this perfect touch. That's tangent line. So we call it secant line has a limiting position as a tangent line because it wants to be tangent. And that's a classic idea. So I found this cool way to explaining it. You don't have to copy it, but I will give it in your notes. This is what we just wrote. I like it with x more than with a. I feel like x confuses us. So instead of a, they put x here. So delta x, this usually is delta. Delta x, whatever we call it h, shrinks to 0 in denominator. Why? Because we're shrinking the interval where I'm looking of my dancing progress. I don't want to look months before and months after. I want to look 5 minutes before and 5 minutes after. Especially for driving, it's seconds before and after. So they say this idea. Step 1, let's choose the interval. For a policeman, it should be a small interval, and we're going to call it delta x. So small interval, because we want to have a touch, a kiss at the graph of the function, of a function. So it should be small. Step 2, find the row change. That gives you, like, okay, what happened when I'm checking whatever it was in the future minus the right now. That's like a very row change, too much. Then find the rate of change. That's the fraction I showed you right away. A rate of change, average rate of change. So your average exam grade will be 5 exams total divided by 5. That is too much. What if I want to know progress today after this exam, whatever we have in 2 weeks? Then you make your model perfect by shrinking the time interval or the input interval to 0. That is the idea here. I kind of like the way they show it here. And I will tell you the cool idea on Wednesday about the Superman. Or maybe I should tell you now. So the idea of the derivative is, or instantaneous rate of change, or derivative of this going to be the same word in the future, literally next week, is the Superman, which, spoiler alert, is a Clark Kent, right? Sorry if I spoiled that. But the Superman is, right now, comes to the office as a Clark Kent, and they have a photo shoot for the job. So he sits in the chair, and then they're making a photo of the Clark Kent. And then he hears that someone needs help. So he's so fast that he changes really fast. He leaves, changes Superman, flies, saves someone, comes back, changes back, and sits down on the chair. The human being eye is so lame that the humans did not notice that, any of this. That's how fast. Well, I guess I'm talking about flash speed, but it doesn't matter. So The person behind the camera never saw the true identity of Clark Kent. And the camera maybe caught it, maybe not. Depends how fast the clicks are, because camera is not continuous. You know it, right? It has time of clicks. So the camera is clicking, and maybe if the click is slow enough, the first click was Clark Kent and the second click was still Clark Kent. Even though between those moments, this person flew away, saved someone, and came back and changed back into the Clark Kent. So average rate of change gives us Clark Kent. But the instantaneous is the one we want to catch. What is instantaneous rate of change? The speed of your car at the moment. Why is 95 miles per hour if you were driving 80 before and now and then 50 after? How this is possible? Well, that's how it's possible. The same with a Superman. If you decrease the moment in time smaller and smaller to catch Superman, you will do it at some point. Your eye will not be able to do it because, again, our eyes are just lame. They don't see fast changes. But the camera might. The good camera with a very 0.001 time interval between clicks, or usually they say 100 of clicks per second or whatever. There's like a measurement there. If it can do it so fast, it will catch a Superman changing there and changing back and leaving and coming back. So that's limit. This is the denominator of this whole idea. The time, number of clicks, shrinking, going to zero. The whole denominator goes to zero. So at some point, I want to catch Superman. So this is the idea. When I make this model perfect, I want the denominator go to zero to catch it. It will never be zero, because remember, it's a limit. But I want to catch the Superman. So making your model perfect means it's physically impossible, but mathematically it is. And that's what speed is, and acceleration, and jump, and all of that kind of cool stuff. I like this example a lot. I feel like it's pretty awesome. Yes?
Can you please show f of a in the graph?
What? Can you say it again?
Can you please show f of a in the graph?
In the graph? Yeah, I'll show later. Don't worry. So, let's do the example from your homework so you feel comfortable with that. Find the equation of a tangent line. Goes back. It's getting back. It's reheating. Just write down. Find the equation of a tangent line. Sometimes the cables are not strong. No? Good. So the problem when we ask you find the equation, EQN, that's the way I write equations because it's just faster this way, equation of the tangent line, and then we always give you of what function and at what point to the curve or graph of the function, that's the same thing, curve, and we give you a function y equals 3 of x, and then we give you a moment, that's tangent, it's a kissing, it's touching moment. So we should give you a moment. It is x equals 3. At x equals 3. So this question, find the equation of a tangent line, will be bothering you with this question, calculus 1, calculus 2, and calculus 3 all the time. So the earlier you learn whatever I'm going to show you right now, it will be the same until calculus 3. Calculus 3 will be almost the same, but then we're going to add like 3-4 dimensions to it. So it's going to be pretty awesome. It will be also tangent plane, not just a line. So the earlier you learn it, the better it is. And I give you steps. Again, you don't have to memorize them. Solution. But students do like my steps. My steps helps your anxiety to go down when you freak out. If you remember my steps, you can do it. Step 1, the moment you see the word tangent, whatever, line, blah, 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 you start with finding derivative. And I did not mention what derivative is, so let's keep calling slope, instantaneous rate of change. So step 1, find slope. Slope is the one that doesn't have limit yet. So m, slope m. Oh, actually, this is the slope with the limit, not the average one. So this slope will have a formula, limit f at a plus h minus f at a over h. One of the formulas I gave you, you need to kind of figure out which one is easier to use. So you will do that. Step 2, Then you need to find the output. We usually don't give you the output. Find the output, f at a, which is, sometimes you call it y sub 0. So the output. If needed, sometimes we give it to you. If we're kind, we give it to you, but on the test, I see that usually they don't give it to you. I received the exam, and by the way, 2 days ago. So now I know what they want from students. And that's very good, because now I see where we're going. Finally, you write down the formula. Y minus y0 equals mx minus x0. There are 2 ways of doing it. Some of you like it as mx plus b. You can do that one. I don't mind. Just know what to do. I always use this one. I don't know. That's just a habit. And that's why I like teaching through this formula. But again, if you like the second one and you know how to use it, go ahead and do that. So what I'm doing here, I was given x sub 0. I found m in the first step. I found y sub 0 in the second step. And I'm ready to write down the equation. The equation, you put everything in, and then it looks good, but we don't like the answer like this. Usually we ask you to rewrite, and that's what your homework says. Rewrite into y equals mx plus b form. So you basically move everything to the right except y. Simple as that. And also it looks better this way. At some point I will tell you why. So those are my steps. Again, you don't have to follow them if you know how to do it. But if you do follow them, you will always succeed. So that's kind of my idea here. You can be creative, just make sure you do it right. Finally, let's do it. I guess let me write down solution over here. Solution. Step 1, they want me to find m. But to find m, I need to know what the heck this formula wants from me. That's the hard part. If you open physics book in the middle, there's like lots of formulas there, you know? You can be very smart, but if you don't know what that formula wants from you, you're screwed. So it's everywhere like that. You need to figure out what the formula wants from you. So let me tell you. Here's the formula, right? We agreed that's what's important. We're just learning this right now. They gave you a. What do you think a is? So we only have 2 things, 3 over x and 3. Which one is a? 3. This is a. I like calling it x sub 0. So very rare I call it a. But your book does call it a, so I decided to follow the book. This is a or x sub 0. X with a tiny 0 is x sub 0. Okay, so I know that a is 3. Now, I don't need to change my h and I don't need to change my f, so I can actually write down the formula right now. The formula will be limit, put h in the denominator right away, else you forget. Denominator shrinks to 0. That's when you want to make the time interval as small as possible to catch the Superman. And then you have f, 3 plus h minus f of 3. This way, actually, it looks better this way to understand what's happening. I want to find the Superman changing at the minute 3. So I'm adding h, which is a small time interval, to catch that change. H is a small change. We have small change in output over small change in input. Bless everyone who just sneezed and coughed. Equals. Now you need to figure out what now. So we plugged a, and now we actually need to solve stuff. H goes to 0. Keep h in the denominator. And now you use your f. And we did it before in 1.3 and lecture 0. We're plugging things into f. So you kind of remind yourself. You can put it on top of this equal sign if you want. F is what? And I give you. We always give you function. 3 over x. 3 over x. So I will plug 3 plus h into 3 over x. Copy 3 plus h, paste into x. Does it make sense? Your old input was x, new input now is 3 plus h. So it's going to be 3 over, and I'm going to color code it, 3 plus h, minus, and then you write down the old version. But let me ask you, is it correct or I made a mistake? The old version is 3 over x at 3. So I need to plug this 3, don't forget about that. Wherever old input was x, now it's 3. So let me make it like this. Very beautiful. I'm very proud of my color coding skills. I like it a lot. So you copy paste, that's the idea. Some of you will be struggling with this moment, but when you get it, copy paste everywhere you had input, it will be a new input. And this is the problem from your homework. This problem kind of on your quiz today anyways. Fraction on the top and then the denominator. What do you do to solve this limit? So the new material always links to the previous material in calculus 1. That's why the more you get behind, the harder it will be to catch up, because it's keep rolling over the old material. How do you solve this limit? Who knows? Common denominator. People are totally too tired on Friday. You create the common denominator. 3 plus h times 3. Cross multiply if you want to call it this way. 3 times 3 is 9 minus 3. Let me write down nicely. 3 times 3 plus h. Common denominator. And this, you had this in your homework, so if you don't recognize it, it's kind of suspicious. You're supposed to recognize this problem. Oh, we also were solving it in office hours, if you came, I think, last week. So, h is in the denominator in black color, but 3 plus h and 3 are also in denominator. So I'm going to merge them together in one denominator. Does that make sense? And then we only have one major numerator. It's this guy. Everything else is in the denominator. That's how you should see it. It's like the numerator is the whole apple. And then I'm dividing the whole apple halves. And I'm like, oh no, I need more pieces. And then I'm dividing those by 3. So in total, I'm dividing halves and times 3. Make sense? 2 times 3. So you're merging denominators together. The numerator will be simplified. 9 minus 9 is 0, so you have minus h. The whole point was to save your limit from dividing by 0 in order to solve it. I don't want to divide by 0, so the goal was to get rid of the bad guy. And the bad guy is this h, stupid h that shrinks to 0. It's in the formula, and we don't like it. So we're going to cancel it out. Minus 3? Good one. Good job. So good catch, good job. So we want to get rid of the bad guy, h. And we did. The next limit, for the exam and quiz, you have to keep writing the limits everywhere. If you don't write the limit, if I don't write the limit, it's actually not correct to put equal sign. So you will lose points for that. I put it on the quiz. Don't forget to write limits, because on the test, we have to take points for that. My limit is an important function, important rule. So you cannot just skip it because you're bored of writing it. 3 plus h times 3. Now you can plug in. What's the answer? Minus 1 over 3. Minus 1/3. Perfect. That is slope. That is slope of the tangent line. Put it in the box. I highly recommend putting all the intermediate and final answers in the box, because the longer the problems become, the harder it will be for you to find the previous answers we need. So box everything you see. That's my habit. I have a good habit to box everything. That was step 1. It kind of was the longest one. Next week, we're going to learn how to make it faster. So step 1 will be 5 seconds long. But in calculus 3, step 1 will be the longest one. Because finding derivative in 3 dimensions will be very fun. It will be so cool. We're going to do matrices. And it's really amazing. Students actually truly love this step in calculus 3. So usually the first step is the hardest one. The second step, let me stare at this formula again. So I'm staring at it. X sub 0 was given. Do you know what x sub 0 is? 3. That's the one we just plugged in. And we just found it. Minus 1/3. So I just need to check if I have this guy. If I do, then I'm ready to write down the answer. If not, I have to find it. Yeah, I don't have it. I don't have y sub 0. What is y sub 0? find y sub 0, which is f at x sub 0, which is f at 3. So whatever they gave you, you need to plug it into original. Plug into original function. Like so. So y sub 0 will be, what's the original function? 3 over x. 3 over 3. So output at the moment 3 is 1. And we are ready to write down the answer. The answer...
How you take these two y not equals to 3 by 3?
Well, can you repeat again?
Why is it 3 by 3?
Let's check. I don't know. Maybe it's wrong. So the original function was 3 over x. I want to plug this one into 3 over x. So 3 over 3, right? Thank you for asking. Yeah, people, you guys should ask. If you don't understand something, if I'm going too fast, which I have suspicious I am, but the first row is responsible to tell me if I'm going too fast. If they're not saying anything, everyone's screwed. No, it's a joke. Everyone should tell me if I'm going too fast. So put it in the box. Step 3, we're writing down the formula y minus y0 equals mx minus x0, or you can use mx plus b if you want. And you have everything. X sub 0, it was given. M, we found it. Y sub 0, we found it. Y minus 1 equals minus 1/3 x minus 3. Let me carefully. Like so. This is the answer, but we just don't like the way it looks. I mean, you might like it, but nobody else likes it. So they always do the step 4, rewrite it. Move everything to the right except y and simplify. Y equals blah, blah, blah. That should be the answer. Y equals 1 minus 1/3 x plus 3 times minus 1/3. That is, well, minus 3 times minus 1/3. That is 1. The answer is minus 1/3 x plus 2. So that's the final step, the final writing down in a nice form. Parentheses. Ask me, what do you think about this? This is equation of a tangent line. Equation of a tangent line. Maybe let me write down. EQN of the tangent line. And then we always give you to what? To parabola, to sine, no, to f of x. That was 3 of x. And then we need to give you a point. Tan 0 minus 17. Well, it better be in a domain, so no 0. So at x sub 0 equals 3. X sub 0 was also called a at some point. And the graph looks like so. Do you know how 1 over x looks like? The hyperbolic function. I will post you a video, all the basic functions. We hope you know. It looks like this and like that. You have 2 asymptotes, horizontal, vertical asymptote. And then they ask us to check what is happening at 3. So at 3, we fix the point 3, and we draw a tangent line touching this function at 3. And this tangent line has equation minus 1/3 x plus 2. Do you know that if m is negative, then the slope going down, the line should go down? So that's exactly what happened. Slope is negative, and now I proved it or double-checked it graphically. But this is a lot of talking, writing down, but this is important. It will be basically hunting you for the 3 semesters. The only difference will be the first step will be different. It will be hard right now, easy next week, hard in calculus 3. So that's kind of the only difference. And we're going to do the same thing in polar coordinates and in different kind of dimensions. Yes?
Do we have our quiz next week for this unit?
Yeah.
Do I have to use the same method that you showed, or can I use a different method
Use the. Are you talking about taking derivative?
Yeah.
Yeah, I will mention it next week because I don't want to distract this week. I just received the exam to let you know what should I say. And the exam says you must use the method they freaking want you to use, which is a long way. It says it on the test. Use a definition of derivative, and if it says after that, if you do not, you get 0 points. I'm like, wow, it's like very angry. There's instructions there. So I was waiting to receive the exam to see what they want.
Okay. So use this method.
Yeah, and then after exam 1, you can use anything else. Then they don't care usually. Yes.
Can you just scroll up?
What?
Can you just
Oh,
scroll?
yes, for sure.
One more.
More?
Yes, ma'am. In the fourth step, you wrote rewrite into mx. Sorry. In the third step, you wrote y is equal to mb plus x.
Yes. Mx plus b.
Yeah.
Oh, you're right. Oh, good catch. Look at that. Fix that. Thank you. Very good.
Ma'am, can you just tell how you went from the 3 plus h minus f of 3 to
Yes.
3 over 3 plus h minus 3 by 3?
Minus 3.
How you went from the first step to the second step?
Yeah, that's the hard one. I would say that's the hard step. So the question is, how did we get from here to here? I mean, to this next line. So f is given as 3 of x. Then we need to write down f of 3 plus h. So I'm taking 3 plus h and putting it on top of x. Old input was x. New input now is 3 plus h. That's the first term, becomes this. Next term is f, again, was 3 over x. But now we want f at 3. So instead of x, I put 3. So that becomes this term. Make sense? So we had f minus f with different inputs. When I write f as the function they gave, it could be sine. Then I plug in 3 plus h. It will be sine of 3 plus h minus sine of 3. So that's, you copy and paste new inputs. Yeah. That makes sense? Yeah, you can totally stay after class, I'll show you more. I think it's easier to show it with other functions than the fraction. Okay, this is good. Let me see how much
So,
time.
ma'am, on the first function, the value of x is 3 plus h, and for the second term, it's 3.
Oh, 3 plus x. For the second term is 3.
Like, you are putting x value as 3 plus h in the first term and 3 in the second term.
Oh, I see. So let me explain this way. This term only wants. Oh, maybe you're asking where this is coming from. This is coming from this formula. Oh yeah, let's go to the very beginning. It comes from the formula, right? Formula has two different f's. F at 8 plus h, and f at a. Then I wrote it down and I plugged in my a only. My a was 3, so now it's f at 3 plus h and f at 3. And then each function have to be now written in terms of the actual function we are looking at, which is 3 over x. X is 3 plus h for the blue color, and then x is 3 for the pink color.
Yes.
How?
Like, for the first term, you wrote x as 3 plus h. For the second term, you just substituted it as 3.
Yes. Okay. Yeah. Should stay after class. I'll show you. I think I know what's the problem here. I'll show you after class. Okay.
May I come like some other day? I have a class after.
It's fine. It will take 2 minutes. Yeah. Just stay after class. Yes.
How'd you go from 9 minus 3 times 3 plus h to the next step, negative 3h?
Oh yeah. I skipped this step here. The step was 9 minus 3 times 3 minus 3 times h. I distributed. And 9 minus 9 cancel out. And you have minus 3 times h. It's some algebra, I just skipped it. Good job, people. Very good questions. More questions. Let's stay after class. It will take me 2 minutes to explain. I think I see what's the confusion here. Let's do the quiz, and I'll tell you how to do it.